here's 27 from the homework where you're given the equation 3x plus 4y minus 8 equals 0, and you're asked to put the equation in slope-intercept form. Alright, so that means we need to get y isolated. Solve for y. What do? Well, I've got 3x over here. I want to move that to the right side. I've got a minus 8, and I want to move that to the right side. So what I do is I just switch the signs for these and put them over there. So I've got 4y left on the left side. I now have minus 3x on the right side. And I'm going to have a plus 8 as well on the right side. So you're just taking whatever's here on the left side, switching the sign, and putting it on the right side. Alright, y is still not all alone. We have to divide everything by 4, so we're going to do that next. Divide everything by 4, and then simplify. So these 4's undo each other. Now I just have a y equals minus 3 over 4x, and 8 divided by 4 is just 2. So now I have the equation in slope-intercept form. Really easy to graph it. We can move over to graphing paper. Always start with the y-intercept. Y-intercept is going to be 0, 2. Okay, so that's right here. And then I use the slope negative 3 fourths. That means, the minus 3 means I go down. 1, 2, 3. And then to the right 4, and that's going to land me right there. So now I've got my 2 points. Take my ruler, and I'll connect them. And here's what the line is going to look like. Right there. Alright, so there's problem 27. Let's do one more. Take a look at problem 31. So here's a bonus problem. 31 was 3x plus 2 times y minus 5 equals 7x. So here we need to do a little bit of review. For 27, if you look back up at 27 for just a half a minute, everything is simplified. I did not have to simplify anything before I started moving stuff to the other side. 31 is different because 31 can be simplified. And so you do always want to check, is there some way I can simplify the equation first? And in this case, yes, there is. Right here, we can simplify this. So we need to distribute, remember the distributive property. We need to distribute the 2 into this expression here, y minus 5. So what we get is 3x plus 2y, right? I do 2 times y, and then do 2 times minus 5, that gives me a minus 10, equals 7x. Now here's something else that's interesting, like in 27 I just had a 0 on the right side. Now I've got 7 x's on the right side. But I'm still basically going to do the same thing. I have these, I want to get y all by itself. So the 3x and the minus 10, they have to go. So if I want to put the 3x and the minus 10 on the right side, I just switch the signs. So I'll have 2y equals 7x minus 3x plus 10. I just took the signs for these guys, switched them, and put them over here with the 7x. Now here's something else that's interesting though. We can simplify this. These are like terms. These are both x's. So what we can do is combine them, and now I've got 2y equals 4x, right? If I have 7 x's and I subtract 3 x's from them, I will have 4 x's left. Plus 10. Y is still not completely isolated yet. I still have the 2 clinging to the y, so I divide everything by 2. After I do that, I get y equals 2x plus 5. So when you're just looking at the beginning, like that looks like something that would be scary to graph. But after you simplify it and put it in slope-intercept form, that can be graphed pretty quickly, right? Again, you always start with the y-intercept. In this case, it's 0, 5. So there's 0, 5. Slope is 2. Now remember 2, so my slope is 2. That's the same thing as 2 over 1, right? So I'm just going to go up 2 over 1. I've got my 2 points there. I can connect them, draw the line through them, and I will be done with that graph.